All right, so we're going to do problem number 8. So the key to these is doing intermediate schematic diagrams. So the first thing I'm going to do is I'm going to redraw my picture because I'm going to use the picture to solve this. So you should be doing this on a separate sheet of notebook paper. If the resistors aren't labeled, you need to label them because, especially with this many resistors, you can lose track. Now this problem, I'm doing the hardest one because it's harder. They don't give you the voltage of the battery. So we kind of have to start backwards on this one. But the key is you're still going to simplify, simplify, and simplify until you have one equivalent resistor. So I just copied this because I'm going to use my schematic diagram to go backwards to do this. So the first thing is I always want to be aware of the current. So the current's coming out of the battery, IT. But I'm not going to worry about this right now. This problem's a little bit different because in the given, instead of us giving the voltage of the battery, they gave me the voltage V3, which is 30 volts. So that's the voltage right here. This is V3 is equal to 30 volts. So because they told us that, we'll probably start there. Now, the total current's coming through here, but then at this point it splits. So part of it goes down here. So I can call the part that's going down here I6, which I don't know what that is. But then part of the current goes here. But what goes through here goes through here and goes through here. Now remember, when we do these problems, what we're going to be doing is we're going to be using Ohm's law for everything. So Ohm's law, V is equal to IR, it has 3 things. So if I have 2, I can find the third. So in this case, I have R, I have V, which means I can find I. So if V is equal to IR, I can say V3 is equal to I3 times R3. So I3 is going to be V3 over R3. So it's 30 volts divided by 10 ohms, which is 3 amps. And in this problem with the math, most of this you can do in your head. You don't even need a calculator. Okay? So now I know that this I3 is equal to 3 amps. That's what I just found out. Now I'm going to cover up the rest of this problem. So when I cover this up, what you see is the current that's going here, that's going here, that's going here, that's all the same, right? And these 3 are in series. And I'm going to say to myself, what is the same in series? Well, I know in series what's the same as the current I. So if this is 3 amps, that means this is 3 amps, and that means that this is 3 amps. Because in series, the current is the same. So that table in your notes that most of you knew for the quiz, but you have to know that for the test. You have to know parallel, you have to know series, and you have to know Ohm's law, and then you're good to go. So I know the current is the same. Now that I have I and R, can I find V? Yeah. So I can find V4 is just going to be I4 times R4. So it's going to be 3 times 5 is going to be 15 volts. And then I can find V2 is equal to I2 times R2. So 3 times 3 is equal to 9 volts. So now for this whole branch, I've already found I and V and R for everything there. And the reason I did that first was because they told me V3 was 30 volts. Okay. What I want to do now is I want to redraw it because I'm going to have to eventually do my intermediate schematic diagrams. Okay. Now when I redraw this, I didn't touch R1, I didn't touch R6, and I didn't touch R5. So R1 is still 1 ohm. R6 is still 6 ohms. And R5 is still 0.5 ohms. That stayed the same. So, because these three are in series, I am now going to replace that with one equivalent resistor I'm going to call R234. To get what R234 is, I'm going to add them in series, because these three are in series. So to get them in series, I'm going to say R234 is equal to R2 plus R3 plus R4. Okay, so R234 is equal to 3 ohms plus 10 ohms plus 5 ohms. 3, 10, and 5. So I can do that in my head. So R234 is equal to 18 ohms. Okay, so now I'm going to redraw this, and I'm going to put here an 18 ohm resistor. Okay, so now this is the equivalent to these three in series, right? Now, why did I do that? I did that because I need to know other stuff. Now, there's more than one way to do this. Remember that in series, what do the voltages do in series? In series, the voltages add up. So I already found the voltage drop across this, this, and this. So these three added up have to be equal to the voltage drop here, right? So if I do that, I know that V234 needs to be V2 plus V3 plus V4, which would be 9 volts plus 30 volts plus 15 volts, which is 54 volts. Okay? So this is 54 volts. But you know what? Maybe I didn't think to do it that way. Or maybe I want to check my work. Well, in circuits, you have a foolproof way to check your work. So I'm just going to show you how I'm going to check that. Now, this resistor here is a combination of these three in series. And in series, the current is what? The same. IT is equal to I1 is equal to I2 is equal to I3, right? So I should know so that the current, so let's say I wanted to find the current here and I use this information. So let's say here I said I is equal to V over R. So I say 54 divided by 18 is equal to 3 amps, right? So I know this is 3 amps. I234 is equal to 3 amps. But remember, in series, the current's the same. So this 3 amps should be the same as these. Is this 3 amps the same as those? Yes. So I didn't have to find the voltage drop this way. I could have looked here and said, well, this is 3 amps, this is 3 amps, and this is 3 amps. So the current going through here has to be 3 amps. And then I could have found the voltage by saying V is equal to IR, 18 times 3. Is that 54? Yes. So there was more than one way that I could have done this. So whichever way I don't do it, I can check my work the other way. So you always want to check as you're going. All right, now, this equivalent resistor, R234, this is in parallel with R6. So now I'm going to say to myself, what's the same in parallel? Voltage. I'm going to say, what's the same? So if this is 54, that means this is equal to 54 volts, right? Now, there's more than one way to do this. I can just keep going and finding the equivalent resistors. Or at this point, if I know the voltage and the resistance, can I find the current there? I can. If I want, I can say that I6 is equal to V6 over R6. So 54 divided by 6 would be 9 amps. Now I already know the current going here is 3 amps and the current going down here is 9 amps. Now remember, here's my total current going through here. Part of it goes here and part of it goes here. So if I wanted to, I could say, you know what, I know the total is going to be 12. I could say 9 plus 3 is 12. But let's say I don't want to do it that way. Let's say I didn't think to do it that way. So what I would do is I would keep going and I would draw my equivalent resistor again. So here I'm going to have R1 is 1 ohm. And I'm going to have R5 is 0.5. And then instead of R6 and R234 in parallel, I'm going to call it R2346. But how do I find the magnitude? How do I find what R234 is? Well, this is, or these two added in parallel. So I would have to do 1 over R234 is equal to 1 over R6 plus 1 over R234. So R6 is 1/6 plus, I found this was 18. So I would find a common denominator. So I would say 3/18 plus 1/18 is 4/18, which reduces to 2 9ths. So 1 over R2346 is equal to 2 9ths. So now I would cross multiply. 9 times 1 is 2 times R236. So R2346 is equal to 9 halves, which is 4.5. So this is equal to 4.5 ohms. Now I see I have 3 resistors that are in series. So if I want to end up with just my equivalent resistor, right, which I want to call RT, I can say that RT is equal to R1 plus R2346 plus R5. So RT is equal to 1 ohm plus 4.5 ohms plus 0.5 ohms. So 4.5 and 0.5 is 5 plus 1 is 6. So RT is equal to 6 ohms. No calculator needed. But in this problem, we want to find everything. We want to find the current and voltage. Now, in this problem, remember, they didn't give you VT. If they gave me VT and RT, I could go back and find IT. But they didn't give me VT. So, you know, I know this is 6 ohms. Now, if I go back, I know that I can go backwards and look at what I found as far as like the voltage, because now I already found that, again, this was 54 volts, this was 54 volts, so this was 9 amps. So I know, again, because these are in parallel, the voltage across these was 9, okay? Now, how did I add these two? These two were what and what? They were in parallel. So you know what? In parallel, I know voltage is the same. So I just want to show you another way. So I know that the voltage going across R2346 also has to be 54, right? Because in parallel, the voltage is the same. So if I just did this little branch here, and I said I2346 is equal to V over R, it would be 54 divided by, oh no, we already did that. 4.5, so 54, I can't do that in my head. So 54 divided by 4.5 comes out to be 12. So that means this is 12. But remember, in series, the current's the same. So that means this is 12, and that means that this is 12. And that also means the total is 12. But you see that I also found 12 the other way, that I said 9 plus 3 is 12. So there's different ways that you can do this to find 12, or I could check my work to see if it was 12. You see that? So now that I know the total current's 12, so again, the current here is 12, 12, 12, I can find the voltage drop here. I can say V5, it's I5 times R5, so 12 times 0.5 is 6, so this is 6 volts. This is 54 volts, and then here I can say V is equal to IR, so I can say 12 times 1 is 12 volts. But I did it kind of, it's not easy to follow there, so we can do it again. You can write it out on the bottom. Did I find the current and the voltage drop across every resistor? Did I do every single one? Did I find I and V for every single one? So let's say I want to check my work again, right? Let's say I'm not sure if I've been doing this crazy problem right. I just found that IT is equal to 12 amps. I know RT is equal to 6, right? So let me just check it. I know that VT is equal to IT times RT. So 12 amps times 6 ohms is 72 volts, right? But I'm not sure if that's right. Now if I go back up here, these 3 resistors are in what? Series. In series, the voltages add up. So that means the voltage drop across this and this and this have to add up to 72. So let's just do that. So VT would be V1 plus V2346 plus V5, and that should be 72. Well, V1 was 12, V2346 was 54, and V5 was 6. So it's 54 plus 12 and 6, 72. So when you do circuits, you always have a way to go back and check your work. And you know, you can do this problem differently because it's what you recognize. How am I going to, should I do this first? Should I do this first? There's more than one way to do it. Okay? So again, you can check, and as I go along, I can always check, you know, what I did. Because every time I work this problem, I would probably do it a little bit differently. Okay? So, again, you can't do these problems without intermediate schematic diagrams. So, again, here I combine these 3 that were in series to get one equivalent resistor. These 2 were in parallel. So then I added those 2 in parallel to get this one. Then these 3 were in series, and that's how I got RT. And that's how we do this problem. There's no short, because when you do shortcuts, you're not going to do it correctly. You can't picture all these intermediate schematic diagrams in your head. This is the correct way to do parallel series combinations. When you don't do the intermediate schematics, you're not actually doing it. You're kind of memorizing. And that's it.